Hey, just a quick note to let you know that this video is a pre-recorded live event. If you'd like to join our upcoming events, such as demos and office hours, you can check out our schedule on our support page. Hope you find this video helpful and look forward to seeing you in our next event. Hi, I'm Jason Wark, and I'm a welfare scientist at Lincoln Park Zoo. Today we're going to be doing a quick demo of our reliability analysis module in ZooMonitor. So if you're not familiar with reliability analysis, this is a way you can compare data between multiple observers or within an observer too. For the purpose of today, I'm going to be talking mostly about inter-observer reliability, and that's where you're comparing data across different observers. And that's what we're going to be showing today in our demo. This video is not meant to be a deep dive on what reliability analyses are, reliability testing. There will be other videos that I'll be posting up soon that go a little bit deeper into those topics. But today I really wanted to just kind of focus on how you can run some of those reliability analyses using some of the built-in features in ZooMonitor. Okay, so let's jump in. Okay, so we are here in our admin area, and you can see there is a button right here for reliability analysis in the behavioral observations module. So you'll go ahead and click that. And here you're going to be filling out, we're going to be filling out a few different things here to set up our reliability analysis, set up our comparison. So the first thing we're going to be doing is selecting a project. So we're going to pick example project Pick Me Hippo for our demo today. Our start date, so we are going to select November 11th. If you're here in the US, that's Veterans Day. There we go, November 11th. So typically the start and end date are probably going to be the same date. You're going to be doing your reliability test with a person alongside them that same date. You could also, if you're using video data, kind of compare back. You could score it once in ZooMonitor and then score that same session again, maybe months later to do more of a intra-observer reliability test. That's also possible, not what I'm going to be showing today, but you can do that here. Your control session. So the control session, what I also typically called the gold standard observer. This is going to be the person that's sort of trained on the project and has the quote unquote sort of stamp of reliability that they're giving. And so for this session here, we're going to be picking my name. And you can see I did a few reliability tests with some office coworkers here, Dwight Schrute and Angela Martin. So I selected my name there for the control session. And for the comparison sessions, I'm going to be picking Dwight and Angela and see how they did. Space use tolerance. So if you hover over, there is an explanation there you'll see on the screen. What space use tolerance is it's basically how far apart are the two dots when you record space use data. How far apart are they? And is that considered reliable for your purposes? And so I can show very quickly a few different images to kind of give you an idea of what we're talking about there. So essentially, let's say we have this habitat image here for pygmy hippos. And these were the two locations. Let's say one of these was myself and one was, let's say, Dwight, recording this data here. And the question is are these reliable? Would you consider these two locations reliable? Obviously, the two observers did not put the same exact location. But unlike with behavior recording, where behavior you're looking, did they put the same exact behavior as you did? Space use is a little bit different. There's probably a little bit of wiggle room around each location that you can consider reliable, and that's what space use tolerance really is getting at there. And so by default, you'll see here in ZooMonitor, it defaults to 30. You can change that to any number you want. You can make it more precise, or you can make it more coarse if you want. That's completely up to you. For the space use tolerance of 30, I did want to show kind of what, kind of give an idea of what that looks like. So if you take that same image and overlay, and you can do this on any of your images, overlay a 20 by 20 grid in ZooMonitor, you can get an idea of what 30, and that's 30 pixels, is, and how far that distance is. And the reason it's 20 by 20 in the grid size is that the image, when it goes in ZooMonitor, gets converted to a 600 by 600. It gets plotted on a 600 by 600 pixel coordinate plane there. And so when you do your 20 by 20 grid, the distance between two of these lines here will equate then to 30 pixels or 30 coordinates in your data. And so to give an idea of that here, you can see I have this example image with 2 dots at each line here. And this running the calculations is 27, roughly 30 pixels apart. So that can give you an idea of sort of how accurate you have to be with 30 pixels. Obviously, if you're, in this habitat, this is our habitat for our pygmy hippos, that might equate to maybe only a few feet. But if you're taking an aerial photo, that distance there, an aerial photo for a different species outside, a much bigger habitat, that distance, may equate to much larger than that. And for some other species that are in smaller enclosures, it may be even much smaller than that. So it really depends, your space use tolerance, what you want to set it at. For Lincoln Park Zoo, just to be transparent, we keep all of ours at 30 pixels for all of our projects as a kind of a rough guide for comparison's sake. But certainly if you wanted to set that on a map by map basis and project by project basis, you can certainly adjust that here. And this little text box here, when you hover over it, basically explains everything that I just said there. And so the distance, I should have clarified, the distance is the Euclidean distance between those 2 points. So it's a straight line distance between the 2 points that it's looking at. So the next thing here on the form is the include modifiers checkbox. So by default, it is checked. You can also click that to uncheck it. What this does is when it calculates reliability, it's going to also include the detail down to the level of modifiers. If you have behavior modifiers, the 2 observers would have had to score the same principal behavior and the same behavior modifiers to be considered reliable. All right, so let's hit Analyze. Okay, so you can see here the table for the reliability analysis module output. And so it is comparing here each compare observer against the control observer in sort of in a pairwise fashion. So for this first line here, you can see it was comparing my data to that of Dwight Schrute, and the channel name here, it's looking at just this interval behavior channel. And so it separates it by these pairwise comparisons between the 2 observers, Dwight and Angela, and then it's also looking at it by channel. And so this first row here, you can see with interval behavior, we had pretty good agreement. So this is % agreement, which is the number of intervals that we agreed on out of the total number of intervals. That was really good. And Cohen's kappa, this score here, so this is basically your % agreement, and it gets modified by an additional factor that looks at the probability that the 2 observers or 2 scores could have arisen from chance. And so this is essentially sort of a % agreement that also factors in chance agreements as well. And then for additional reference here, you can also look at a 95% confidence interval around the Cohen's kappa score. And so just to kind of look through and go through this table, so you can see Dwight and I were pretty good on behavior, we got one wrong there. And then interval height and space use, 100%. Angela did really great on the behavior channel, but had a few wrong on height. And so if you want to dig down and see, for instance, what was the interval that Dwight and I got wrong for behavior, you can click this details button right here. And this will pull up a interval by interval table that lets you look at all of the recordings that you had. And you can see in the right column here, the 0, this is the agreements. And this is the one where we did not agree. So this was interval 5. We were scoring data on Annie. And I had scored inactive as the behavior. And then I had put the modifier alert and head up. And Dwight had scored inactive, but put the modifier of rest and head down. So this is an example of, because we had include modifiers, this was considered not an agreement. But if we had that unchecked, and we were not including modifiers, this would have been an agreement here because we did both put inactive. We just disagreed on the modifier level of what we scored there. And then if you scroll further down, you can see a confusion matrix, which for many people is probably aptly named because it is confusing. But what this is looking at is this is the data that's used to calculate your Cohen's kappa score. And so you're basically taking the scores from the one observer and the other observer and putting them across each other. And so down the center column here would be all of the agreements. And then the ones that weren't on the center column here. So this one score here, which was our inactive where we disagreed on the modifier, this is the disagreement here. And so this is just another helpful table if you wanted to understand how Cohen's kappa was calculated or calculate it yourself. This can kind of help you run some of those calculations and numbers manually if you'd like. And there's a few ways to export your data from this. So you can export all of your data here by clicking, if you click Export Excel, that exports this table that you see in front of you. And then alternatively, you can click Export All Data Tables, which is not going to export this data here. It's actually going to export every one of these data tables that we brought up. So it's going to export all of this interval by interval data. And so when you open the detailed results here, you can see you also have an option to individually export just one data table if you want. But more often than not, you want to store a record of all of the interval by interval scores that were recorded. And so that's where this export all data tables is a really helpful option there. The last thing I wanted to note here too, in looking at the data, is sort of how ZooMonitor handles missing data. And so here you can see we scored all 10 intervals, both Dwight and I did. But if Dwight had missed one of these intervals, if there was a blank here, it would score that as a disagreement because I had scored a behavior and the person you're comparing to did not have a behavior, so that's a disagreement. However, if I had missed a behavior, let's say I had a blank here for this interval and I did not score a behavior, it would not count that as a disagreement. It actually wouldn't count that in the reliability comparison at all. And so you can see an example of that if we go back and we compare the session at 4:40. So you can see here, for this case, there was a missing interval here. So there's only 9 out of 9. So it still gives you 100% agreement, but there was only 9 intervals recorded. And you can see looking at each of the intervals here, it was an observation with Howie and it was interval 6. That was an interval I missed recording behavior on, but it's not going to count that against Dwight that I missed recording that. So it just basically does not include it in the calculation. All right, I hope that was a helpful quick overview of our reliability analysis module and helps you quickly make some of those comparisons and ensure you have reliable data that you're using in ZooMonitor when you're analyzing your data. If you have any questions, of course, always feel free to reach out to me at support, and you can always check out our support site and any of the other videos coming up on the ZooMonitor YouTube channel. Hey, thanks for watching. If you like that video, be sure to hit the like button and subscribe to our channel to be notified when we release more videos. If you have any questions about ZooMonitor, you can always feel free to contact us at ZooMonitor@lpzoo.org. Thanks.